Alright, now we're going to look at some special matrices. Okay, if there is a matrix that has only one column, that is only a single column, there's a special name for it and we call it a column matrix. So for instance, in this example given here, alright, we say that this is a column matrix because it has only one column. Similarly, for any matrices that has only one single row, we call it a row matrix. Okay, so sometimes you will come across this in questions where they refer to it as a column matrix or a row matrix. So you need to know that this refers to matrices that have only one row or one column. Okay, the next type of special matrices that we've seen before is called a square matrix. And like what the name implies, the square matrix will have the same number of rows and columns. So for instance, in the first example here, this is a 2 by 2 matrix. It has 2 rows, 2 columns, so we call it a square matrix. The next example, okay, this is a 3 by 3 matrix. Similarly, because it has the same number of rows and columns, so it is also called a square matrix. Okay, we have come across a square matrix, in particular a 2 by 2 matrix before in A-Maths. Okay, the third type of special matrices are called zero matrix, or sometimes we refer to it as null matrix. Okay, this happens when all the elements are 0. Okay, so null matrices can take any order. You can have null matrices of any size. But what you take note is that you notice that all the elements inside are all 0. Okay, so we have seen row matrices, column matrices, null matrices. Next, what we're going to look at are some properties of matrices. So if I have two matrices A and B, and if they have the same order and the exact same elements, then we can conclude that matrix A is equal to matrix B. Please note that two matrices can only be equal if they satisfy the first condition, and that is they must have the same order. So for instance, if you look at the example, okay, if I have matrix A is this, and matrix B is this, if you simplify matrix B, this is equals to 1, 4, 7, 8. You find that they are okay, they have the same order and their elements are exactly equal, so we say that they're equal matrices. Okay, how do we make use of this? Sometimes the question will tell you, okay, A and B are two equal matrices, but there are actually some unknowns A and B that you have to find. So given the fact that they're equal matrices, we can then conclude by comparison of the elements that A must be equals to 3 and B must be equals to 8. So a reminder again, okay, let's say if I have two matrices 3, 5, 7, okay, this, if you recall, is called a row matrix, and I have another matrix with the exact same elements but represented as a column matrix. Please note that these two matrices are not equal. Why? Because they actually have different orders even though the elements are the same. One is a 1 by 3 matrix, whereas the other one is a 3 by 1 matrix. So it is very important that for the matrices to be equal, they need to be of the same order.